So a cubic function is given and it said that it has a relative maximum at x is equal to alpha and relative minimum at x is equal to beta. That means these are the stationary points. So we have to prove that alpha plus beta is equal to minus 2/3 a, and also we have to prove that the point of inflection is at x is equal to alpha plus beta over 2. So to do the first one, we know that the maxima at maxima and minima, when it happens when it's stationary points, it said it's stationary points, that means the first derivative becomes 0, the gradient becomes 0. So fx, I will rewrite the function here. So x cube plus ax square plus bx plus c, that's the function. So the first derivative will be 3x square plus 2ax plus b, that's the first derivative. So at x is equal to 0, sorry, that's stationary points where maxima minima are there, the first derivative will be 0. So this one is 0, and this is a quadratic equation, so it will have two roots. So the roots are, we know that for a quadratic equation the sum of the roots will be alpha and beta, and we know for a quadratic equation the sum of the roots are minus b over a. That means b is the coefficient of x term and a is coefficient of x square, of course. So alpha plus beta is minus b over a. Here b is 2a, the coefficient of x, and coefficient of x square, which is a, is 3. So that's it. So this is the first part that we needed to prove basically. Now in order to do the second part, where the point of inflection, we have to show that this is the point of inflection, x is equal to alpha plus beta over 2. So we know that point of inflection is where the second derivative is 0. So first derivative is this one, 3x square plus 2ax plus b. This is the first derivative. So second derivative will be 6x plus 2a, and at point of inflection second derivative will be 0. It has to be 0. This is a necessary condition. So 6x plus 2a is equal to 0. We are getting a value of x here, which is minus 1/3 a. We need to prove that x is equal to alpha plus beta. So we have something from of alpha plus beta from the first identity that we proved, this one, which is also this one. So we will rewrite this minus 1/3 a as half here times minus 3 over 2a. So basically this one is alpha plus beta. So we are trying to write it in terms of alpha plus beta. So this part is alpha plus beta. So here we go, we get the second part. But we also have to show that this is actually a point of inflection. So in order to do that, we have to check whether the sign of second derivative changes going from the left to right of point of inflection. So point of inflection is where the curvature changes. So basically it goes something like that, and this is probably, if this is a point of inflection really, then the second derivative can be 0. That doesn't mean it is a point of inflection. It is, to check whether it's a point of inflection, we have to see what is the second derivative to the left and what is to the right, and if they are of opposite signs, then it's a point of inflection. That means the curvature is changing going from the left to the right. So let's say we go a little bit to the left from the point of inflection, which is, let's say, to the d. So fx minus d, a little bit. X is this is the point of inflection, so I will write what is the point of inflection there. So which is minus 1/3 a. So basically going a little bit to the left from the point of inflection here. So 6x was the f double prime x, this one is 6x. So instead of x we will write minus 1/3 a minus d plus 2a. So that will be minus 2a minus 6d plus 2a. So minus 6d. So if d is positive, this is a negative. We are getting the value of the sign of second derivative to the left of the point of inflection as negative. That's fine. Now let's see what is the sign of the second derivative on the right of point of inflection. So going to the right a little bit, same as much. So 6 1/3 a plus 2a. So this is becoming minus 2a plus 6d plus 2a. So this is plus 6d. So this is positive. The second derivative to the right of the point of inflection is positive. So the sign is changing going from the left to right. So that means this is a point of inflection because the second derivative is 0 and the sign of second derivative going from the left to the right of that point is changing. So that's a point of inflection concluded.